next video, we're going to talk about rules for limits. So we understand at this point the general idea when we have a limit is to try and plug that value a that x is approaching into whatever function you're given and to see what the output is. Of course, sometimes we can't do that and we have to use some algebra to manipulate. So we're just going to talk right now about some rules that we can always use to help us find these limit values, and then we'll do a bunch of examples of finding limits. So with our rules, the first rule we have is the constant rule for limits. So if your function is a constant k, then the limit, regardless of the value it is approaching, is always going to be that constant. Our second rule is the rule for finding the limit of a constant multiplied by a function. And essentially this means if we have some constant multiplied by the function in our argument of the limit, that constant can be pulled in front of the limit. So you would find the limit of the function and then multiply it by that constant, which you've already pulled in front. So basically, you can just pull a constant out in front. Our third rule here is the sum or difference rule for limits. So if I have the limit as x approaches a of some function that is made up of lots of separate terms. Essentially what that says is I can divide that, I can split it at each plus or minus sign into separate limits. So the limit of f plus g is going to be the limit of f plus the limit of g. So, and just looking at our rules here, we were defined up above the limit of a, or the limit is x approaches a of f of x is a, the limit is x approaches a of g of x is b. So finding each of those limits individually, we would just add them together. Next, we have a product rule for limits, which essentially says the same thing. The limit of a product is going to be the product of each of those limits. So the limit of the first thing you're multiplying times the limit of the second thing that you're multiplying in that argument. You calculate each of those limits individually, and again, then you would just multiply them together at the end. Now, I was able to include sum and difference together because adding is essentially subtracting, and that's the same with multiplying versus dividing quotients. The difference is the denominator can't be equal to 0, right? So the limit of a quotient is the quotient of the limits. So the limit of this quotient, f over g, is the quotient, the limit of f over the limit of g, which would then be a over b, because those were the limit values that we get. And the only thing we say here is that whatever we have in the denominator, b, can't be 0. So essentially, the product and quotient rules could be the same, but we have this, hey, denominator can't be 0, so they separate this one into two different rules as well. All right. Now that we know the rules and we can use those rules to simplify limit problems, let's look at a couple of examples. In this example, we're given the fact that the limit as x approaches 4 of some function f of x is equal to 9, as well as the limit as x approaches 4 of a different function g of x equals 27. For part A of this example, we're going to find the limit as x approaches 4 of 2 times f of x. Now, one thing to note is that both of these given limits are approaching 4, and the problem we're solving is approaching 4. You are really not going to see them with different values of x that you're approaching, but it is important to note that that must be the same in order for us to apply these rules. So in this situation, we would look at that 2 as a constant multiple, and I'd rewrite this as 2 times, I'll factor that 2 in front, the limit as x approaches 4 of f of x. Now, of course, we know from what was given that the limit as x approaches 4 of f of x equals 9. So this is equal to 2 times 9, or 18. For our second example, we're given the limit as x approaches 4 of g of x divided by f of x. Now, this can be separated. The limit of a quotient is the quotient of the limits into two limits. So this is the same as writing the limit as x approaches 4 of g of x, which is the function in the numerator, all divided by the limit as x approaches 4 of f of x, the function in the denominator. Now we know what the function in the numerator is equal to, 27, and in the denominator we get 9. So this would simplify, and this conceptual limit problem would solve and give us 3 as the limit of the quotient. That's the end of this video. In the next video, we're going to really look at applications of these problems onto real functions as opposed to more this conceptual idea. Always remember, feel free to email me or comment if you have any questions or concerns.